Well, let's look at number 5. Given h is this piecewise function, find the derivative of h at 1. And I've actually already worked this out to determine continuity. If we want to find differentiability, determine the derivative at a point specifically, we need to make sure we have continuity, and we do. And here's what I had worked out previously. But I was filming a video and then it got interrupted. That's what happened actually. So what I had was, is the function defined? And does the limit from the left equal the limit from the right? And yes, therefore the function is continuous at x equals 1. So now I'm going to find the derivative at 1. And at this point, I'm going to just kind of go with the shortcut. And here's the shortcut that will not work on a free response question, okay? So as we go forward with number 5, I cannot look at this and say, oh, the way I'm going to do this with a shortcut is going to be great for a free response. No, it's not. It's great for multiple choice. So follow me on this. If I wanted to find the slope at 1, I would do this. This should look familiar. The slope is this, but I'd have to make sure it works from the left and from the right. Well, so here's the deal. If I took the derivative of this function, and again, what I'm showing you right now is fantastic and wonderful, but not valid explanation enough to get points on a free response question. So if I took the derivative of h, I would have, well, 4x, see, shortcut, 4x, and here I'd have 4. And this would apply where x is less than 1, and this would apply where x is greater than 1. And notice that I didn't say that this is less than or equal to 1, because I don't know that yet. So I really don't know if the function is truly differentiable at 1. We do have continuity, we determined that because the function is defined, the limit from the left equals the limit from the right, so we're good, we got that. And again, it's not been written this way before, but we have continuity. But what I really want to know is, does the derivative from the left equal the derivative from the right? And yes, it does. Because if I plugged a 1 in here, I'd get 4. If I plugged a 1 in here, well, I can't, and I'd get a 4. Therefore, h prime of 1 is indeed 4 because the slope from the left matches the slope from the right. And because it does, I could say that this is truly equal. Okay, look at number 6 for just a second. And let's figure out what it's asking. Find the limit as h approaches 0. Oh, it's a limit question. No, it's not actually. It is not a limit question, nor is number 7. Number 6 is actually a question that's asking us to find the derivative. Okay, so let's shift gears for a second and switch colors. This should look familiar. The limit as h approaches 0 of f of x plus h minus f of x over h. Okay? This is the derivative at some value x. That is exactly what we're looking at here, and it's actually what we're looking at here. So now the question is, okay, what are we taking the derivative of? Now again, you might say, this is a limit question. It is and it's not, because this structure is this structure, which is really a derivative question. So let's determine what we're really looking at. So here's what we have. Well, we obviously have an h, and then 3 plus h to the 4th. So this x plus h is really 3 plus h. And the biggest thing happening, and this is worth writing down, the biggest thing happening is, if we were to define this function, my function would be somebody got raised to the 4th power, okay? And it makes sense. Somebody got raised to the 4th power. Well, who got raised to the 4th power? 3 did. See, 3 to the 4th power is 81. And here's your 3 anyway. It's kind of staring you in the face. So basically, my function is x to the 4th, but this is a fancy way of saying I need to know the derivative of my function at 3. And again, here's why 3, and because 3 to the 4th. So, well, I need the derivative at 3, so I need the derivative in general, which would be 4x cubed. So now I'll find the derivative at 3. So 4 times 3 cubed, so that'd be 4 times 27, which is 108. Yeah. Okay, same thing for number 7. This structure is that structure, so we're just going to find the corresponding parts. Now, instead of h, they used delta x, which again represents the change in x. So let's do it. What are we dealing with here? Okay, well, we have something that's squared minus something plus 5. Oh, there we go. Minus squared plus something minus 5. I know the signs are different. If you wanted to, you really could say that what I have here is minus 4 squared minus 4 plus 5. Okay, so that's the same as that. We could do that if we wanted to. They are the same thing. And that helps us really recognize the structure of our function. So let's find what our function is. Our function is really, okay, well, somebody got squared minus that same thing and then plus 5. Now you're probably like, well, what about the 4? Okay, that's great. That's what they're asking. They want to know the derivative at 4. And that's why the number 4 keeps popping up. Now, 5 is part of the function, okay? And here's how we know. X plus h, or x plus delta x. X is 4. So we want to know the value of the derivative at 4. So let's find the derivative. And now let's find out what happens if we plug in a 4. 2 times 4 minus 1 gives me 7.